everyone. For this discussion, I chose to research how retailers use big data and time series analytics to improve business performance during the holiday shopping season. The example that I chose for this was Alibaba's Tmall platform, which is one of the largest business to consumer e-commerce platforms in the world. The reason I chose Tmall is because researchers have clearly documented how the library used historical sales data, seasonality analysis, and predictive models to improve sales forecasting. For the first part of this presentation, I'll discuss the problem Tmall was trying to solve, the analytical techniques that were used, and the results and limitations of those efforts. Then, during the last few minutes, I'll share my screen and walk through how I completed the Unit 4 assignment using logistic regression in RStudio. Holiday demand can be extremely difficult for retailers to predict. Sales usually start increasing in October and continue through November and December. However, that increase is not consistent across every product, seller, or a year. One product may become unexpectedly less popular, while another may not sell as well as forecasted at all. This is where using real-time analytics can be useful. Unlike an analysis that looks at unrelated observations, time series analysis keeps the data in chronological order. This allows a company to identify trends, reoccurring sales or seasonal patterns, and changes in customer demand over time. By using accurate forecasting, businesses can determine how much inventory to order, when to launch promotions, and how many employees may be needed to staff. If the demand is underestimated, popular products may run out, causing them to lose potential sales. If they overestimate the demand, then they could have an excess of product that could eventually be discontinued. And Safi and colleagues explains that retailers use several forecasting techniques, including those such as exponential smoothing, SARIMA, conventional neural networks, and long short-term memory networks. The appropriate method depends on the data and the business problem that is being addressed. In the Tmall example, researchers analyzed large amounts of historical sales data from retailers operating on the platform. The selected data can contain repeated sales observations across several different retailers and product categories. When researchers analyzed the selected records, they discovered that different groups of retailers had different seasonal patterns. This means that not just one sales cycle was able to accurately represent every seller. To account for these differences, researchers use a technique called Fourier decomposition. It was straightforward and represents repeating patterns through a combination of waves. This helps to recognize recurring sales cycles and convert those into features that can be used to predict future sales. Researchers recognize that retail sales data have skewed highly. To address this problem, they use a logarithmic transformation. These techniques were applied to neutral network and gradient-boosted decision tree models. The overall objective of this was to estimate how much each retailer would see in the future. The forecast could be used to support inventory decisions, promotional planning, and fulfillment capabilities, as well as evaluating the retailer's future business potential. Researchers have reported that both seasonality extraction and transformed Tweedy loss approach significantly improved forecasting performance. The reason that this is important is because having better forecasting gives retailers a stronger information model for making sure that they are making revenue-related decisions. An organization that can anticipate demand and more accurately position themselves to have popular items in stock, reduce unnecessary inventory, and prepare the fulfillment operations for an increase in orders. It's important to distinguish between improved forecasting and proof of increased revenue. The analytical techniques demonstrated the improved forecasting accuracy, but it doesn't prove that a specific model alone generates a specific amount of revenue. In addition to this, there are several limitations. Historical patterns cannot predict unusual events, such as supply chain disruptions, economic changes, or having a product suddenly become popular on social media. This is also less accurate due to changes in customer behaviors. Overall, the Tmall is a strong example of how a company uses big data and explicit time series techniques for improving sales forecasting and strengthening revenue-sensitive decisions. For the remainder of this presentation, I will walk through how I completed the Unit 4 assignment. The purpose of this assignment was to use a generalized linear model, specifically logistic regression, to predict whether loan applicants represented a good or bad credit risk. The process that I used involved importing and verifying the data, building a full model, refining that model, generating probabilities for new applicants, and translating those probabilities into lending decisions. First, I imported the loans.csv and applicants.csv datasets into RStudio. The loan dataset contained historical application information and the known credit risk outcome needed to train the model. The applicant dataset contained new cases that needed to be evaluated. In completing this assignment, I used the head and summary functions to confirm that the datasets were loaded correctly and that the variables were in the expected structure. This step is important because missing data, formatting problems, and incorrectly defining variables could result in unreliable results. Next, I created the full model using R's GLM function. I specified family being equal to binomial because that is the dependent variable, such as good risk, and has two possible outcomes. Borrower characteristics were included as possible predictors, but excluded the applicant ID because it was an identifier and didn't provide predictive information. The model summary provided coefficients, standard errors, z-values, and p-values that were needed to determine which variables significantly contributed to predicting credit risk. After the full model review was completed, p-values for each predictor were compared with a standard significance level of 0.05. Credit score was a strong predictor with a p-value of approximately 1.73 times 10 to the minus 5 power. Monthly income was statistically significant with a p-value of approximately 0.0098. Age in years and lines of credit were not significantly statistically represented in this data set. Based on the results, I created a reduced model that contained credit score and monthly income. This produced a model that was easier to interpret, but the variables removed should still be considered when the model is updated with new or more diverse data. Next, the applicant's dataset was applied to the reduced model using the predict function with type equal to response, converting the output into the repayment probability ranging from 0 to 1. Lastly, those probabilities were interpreted using several decision thresholds. At the standard 50% threshold, 49 of the 82 applicants were considered as good risks, while 33 were considered as bad risks. The model also identified 48 applicants with repayment probabilities of 75% or more, and these lower risk applicants might qualify for expedited approval or more favorable loan terms. On the other hand, there were 32 applicants that had probabilities lower than 25% and represented the highest potential default risk and could require additional collateral, a qualified cosigner, further review, or even denial of their application. Applicants with a moderate risk could receive a manual review or risk-based pricing. The point of that probability should represent the lending decision rather than automatically making it. The thresholds should also reflect that the lender's risk tolerance, regulatory requirements, model validation results, and fairness considerations are in place. This completes my walkthrough of the Unit 4 assignment and my discussions of time series analytics and holiday retail. Thank you for your time and listening to my presentation today.